let's next look at this problem. Find the volume of a solid obtained by rotating the region bounded by y equals x squared, y equals 1, y equals 4, y equals 0. X. X equals 0 about the x-axis. So if I draw that that particular region, I got y equals x squared, parabola, y equals 1, and y equals 4, and then x equals 0, so that's the y-axis. And so, yeah, I'm looking at this particular region right here, and I'm rotating that about the x-axis. All right, well, hopefully here you would take, if we look at our typical rectangle, which helps us decide which way we want to integrate, that typical rectangle we would want is horizontal. I'd want to take the typical rectangle like this because that way I'm only going between the y-axis and the curve here. If I do typical rectangles the other way, well, I'm going from here up to here, which is between two horizontal lines, but then I'm over here, I'm going between the curve and that horizontal line. So I'd have two different integrals, whereas I can just do one integral the other way. So integrate with respect to y. Now, it also tells me, because I didn't explain which method to use, but we can see here I've got the typical rectangle is this way, the axis of rotation also is here, it's the x-axis, so that typical rectangle is parallel to the axis of rotation, and so as we know that, as we talked about before, that would mean, yeah, that's going to be the shell method. Now, don't think we've done one where we had the shell method, and this means we're integrating with respect to y, right? The horizontal typical rectangle, that's integrated with respect to y. And so let's talk about that. So the shell method, integrated with respect to y. Well, what that means is everything in the shell method needs to be regular shell method for integrating with respect to x is a to b 2 pi x f of x dx. And so if we're doing the shell method, we integrate with respect to y, then that just changes all the x's over to y. So it'd be 2 pi y times f of y dy. And of course, then I would go from c to d, usually the way we denote the y values like that. Yeah, so in this case, here's what I need. So I've got 2 pi y. Yeah, I need an f of y, which means I need an x equals f of y function. In other words, our function, in most cases that we'll need, is going to be to be this type of equation. That way we can establish what f of y is. Well, our function here is y equals x squared. Well, that's not in x equals f of y form, that's y equals f of x form. And so I need to adjust that around and make it an x equals equation, if you will. And so I need to solve this for x, get x on the side by itself. So in this particular case, if I square root both sides, basically what I'm doing here, then that'll get rid of the squared. Yeah, so x, this piece anyway, would be x equals, instead of y equals x squared, we could call it x equals the square root of y then. And that's, of course, what we would need to call our f of y, because that's where our function, our rectangle, or where we're integrated to there. So our f of y squared y dy, and of course we've already got c to d, that's the y values that I'm going from, so it'll be from 1 to 4, lower limit's 1, upper limit's 4. So this is our integral to evaluate this volume. Yeah, and so I would need to combine that. Well, square root of y, y to the 1/2. And so what I've got here is 2 pi. So I've got y times y to the 1/2. That you would add those exponents. So 1 plus 1/2 is 3/2. Combine those. So now I can do the antiderivative. Y to 3/2, the antiderivative, add 1, you got 5/2. So I multiply in front here by 2/5, and then that's going from 1 to 4. So I've got 2 pi times 2/5 times, it'll be 4 to the 5/2, and then minus 2/5, 1 to the 5/2. So that gives me 2/5. Let's see, that would be denominator 2 means square root, so it'd be the square root of 4, which is 2 to the 5th, 32. Do it that way, and then of course 1 to anything is 1. So we've got what, 64/5 minus 2/5. That'd be 62/5. And then times the 2, so I've got 124 over 5 pi. Be the volume of this thing. Here. All right, is that okay? All right, let me give you a couple more, just again to get the idea behind, which method to use, because there's a couple in the homework where you have to decide which method to use or apply that. So take a look at this. All right, so let's say the region bounded by y equals x and y equals x squared. Number 1 is rotated about the x-axis. All right, so we want to find the volume there. Well, so we got y equals x. We know that that line looks like 45-degree line, whatever you want to call it. And then of course y equals x squared, our little parabola here, like that. And I'm going to rotate it about the x-axis. All right, well, it looks, so this little piece right here, rotating that about the x-axis. All right, well, the typical rectangle here, if I do it and I do it vertical here, that seems to look like it'll work out pretty nicely because I'm just going from this one to this one. So let's go with the typical rectangle this way, which means, for one thing, it means I'm integrating with respect to x, which is the one I'm more used to, I guess. But the other thing, though, is which method is that? Because it didn't really specify which method. Well, again, if you look at the rectangle compared to the axis of rotation, those are perpendicular. And if the rectangle and axis of rotation are perpendicular, that is, well, it's the disk method, but in this case, we call it the washer method because it's going between two curves. So it's washer method, which volume equals integral a to b pi times, and then the deal is it's just kind of an altered form of the disk method, what I call it anyway. This method, you got f of x squared, but when you got this washer method if you're going between two, right? So the deal is then you subtract then the g of x squared, where the f of x squared is the outer one, upper one in this case, and then the g of x is the lower one. And let's see what that is in this case. So it'd be pi times, so the outer one or the upper one here is the line, the y equals x, so we'd square the x. And then the g of x squared, well, that would be the lower one, which is the x squared one, so I would do x squared squared. Subtract those two and integrate. The a to b, probably fairly obvious, but again, just to confirm, to get where these two intersect, just set them equal. X squared equals x, so that'd be x squared minus x equals 0. If I drop an x times x minus 1, so that's x equals 0 and x equals 1. So 0, 1 is my limits there, are my limits. All right, so that's, let's go ahead and evaluate this as be x squared minus x to the fourth. And then simple little antiderivatives, 1/3 x cubed minus 1/5 x to the fifth. Evaluate that from 0 to 1. So we've got pi times, plug in the 1, you got 1/3. Plug in the 1 here, so you got minus 1/5. And then of course zeros. Plug in the 0, you get zeros in this one. So you basically got 1/3 minus 1/5, which that's 5/15 minus 3/15. It's 2/15 times pi. Now, let's take it the other way, though, and rotate it about the y-axis and see what that would mean. So same two curves, but we're going to rotate it about the y-axis. So the two curves, so I'm going to take this one, same two curves. But I'm going to rotate it about the y-axis. Well, yeah, I do have a choice here. I could integrate with respect to x or y, but let's just keep integrate with respect to x. Let's still just do the typical rectangles. Vertical. Well, of course, what that changes is, since the axis of rotation is the y-axis now, the typical rectangle and the axis of rotation, those are parallel. And as we know, it's parallel, that would mean the shell method here. And it is the shell method in this case. I'm integrating with respect to x because it's the up and down vertical rectangles. So that's 2 pi x times f of x dx b. And we already know a and b are 1, same 2 points of intersection. Then the 2 pi x. All right. So in this case, that's our simplified version of shell method. What the f of x in the shell method means is that, if you go back to how we developed it, the f of x is actually kind of a height function. And so we're talking about the height of the rectangles, or the height that we're covering here. And so, yeah, again, if you've got the height of the rectangle between two curves, you're just going to subtract, do the upper one minus the lower one. So the height here is the upper one, which is the y equals x, minus the lower one, which is the x squared. So this is the integral here of this particular curve. So that's 0 to 1, 2 pi, and remember on these, usually the ones we do anyway, they are distribute the x and then do the antiderivative. So the x squared minus x cubed dx. So that's 2 pi, the 1/3 antiderivative, 1/3 x cubed. Antiderivative there is 1/4 x to the 4th. And do that from 0 to 1, so you'll have 2 pi Plug in the 1, you'll have 1/3 minus 1/4, and then zeros give you 0. So 1/3 minus 1/4, 4/12 minus 3/12 is 1/12. So this is 2 pi times 1/12, which cancel the 2 out, be pi over 6. Pi over 6 would be the volume right there. Okay?